Now that we have a more detailed understanding of conductors and insulators, it makes sense why there would be a need for something to regulate the amount of electricity being conducted and insulated. What materials we use to conduct electricity throughout our homes is more important than I thought. Let's take a trip to the lab to learn more about conductors, insulators, and resistors from Dr. Kasporkian. Hiya, Dr. Kasporkian.
Hello! I heard you were coming by to learn all about what conducts, insulates, and resists electricity. Conductors are materials that allow electrons to flow freely from particle to particle. They also allow for the charge transfer through free movement of electrons.
So if a conductor is touched to another object, the conductor can transfer its own charge to also charge the other object? How cool is that?
Very, very cool indeed. Now, insulators are somewhat the opposite of conductors. They're materials that stop the free flow of electrons from particle to particle. Because of this, the charge is rarely distributed evenly across the surface of an insulator. Conductive objects are often mounted on top of the insulating objects. This arrangement prevents charge from being transferred from one conductive object to its surroundings. This arrangement also allows for a student like you to manipulate a conducting object without even touching it. This insulator serves as a handle for moving the conductor around on top of a lab table.
If charging experiments are performed with aluminum soda cans, then the cans should be mounted on top of styrofoam cups. The cups serve as insulators, preventing the soda cans from discharging their charge. The cups also serve as handles when it becomes necessary to move the cans around the table. Dr. Kasporkian, what are some examples of conductors and insulators?
That's a great question, Miss Priscilla. Aqueous solutions of salts, like ionic compounds dissolved in water, graphite, and my absolute favorite, the human body. Examples of insulators include plastics, styrofoam, paper, rubber, glass, and dry air.
Cool, well, bye! Wait, what about resistors?
Well, I'm glad you asked that. I almost thought you forgot for a second. The resistor is a part of an electrical circuit that resists or limits the power of an electrical current in a circuit. The resistor also helps to reduce or lessen the amount of electricity moving through the circuit.
So what you're saying is resistors are important to circuits because they reduce the amount of electricity traveling by a current through a circuit? Does that mean that this ensures that the right amount of electricity is provided to an object that needs electricity to work?
That's right, Miss Priscilla. So remember, conductors allow electrons to flow and can transfer their own energy to charge another object, while insulators don't allow electricity to flow at all. Resistors regulate how much electricity flows through the entire circuit to make sure objects don't get too much or too little electricity.
Well, that's awesome to know. Thank you so much for helping us today, Dr. Kasporkian.
Thank you so much, Miss Priscilla, for stopping by.
Okay, bye.
Bye.